We are back with another lesson. I'm not going to lie to you guys, lesson 5 over inscribed angles. This is by far my favorite circle lesson. So yay, maybe that's good news. Maybe my opinion means nothing. Let's find out. So the setup is the same on this lesson as it was with the last two. There were 2 theorems. I kind of just explained what they said, and then I showed you how to use the theorems. We're going to do the same thing here. 1 theorem on the front, 1 theorem on the back. No proofs. We could write proofs, but we're not going to. All right, so theorem 1, let's just jump right in. Quick reminder, a central angle. We talked about this in lesson 1. A central angle is just an angle that's located at the center. The vertex is at the center. So something like that. That's a central angle. Let's say that it's 40 degrees. Remember that a central angle, it has an arc that it goes with, around the circle. If you kind of look at the angle, it's going to hit the circle in 2 places, that arc between those 2 spots. So here, this arc. Remember that a central angle and the arc that it goes with, they have the same measure. They're the same degrees. They call that the associated arc. So we'll roll with it. Those are the same. But what about this picture? So no longer is the vertex in the center. They took the vertex of the angle and they pulled it all the way back to the other side of the circle. That changes things. The arc and the angle are no longer the same in this situation like they were here. So let's explore. This is called an inscribed angle. Topic for today. So angle B here, that is an inscribed angle. And all that is it's just an angle formed by 2 chords. Learned that word last time. 2 chords whose vertex is on the circle. Don't let all that wording freak you out. AB is a chord. CB is a chord. The vertex is B there. So point B is the vertex. That's on the circle. There's my angle formed by 2 chords. Okay, that's called an inscribed angle. It's inside the circle. That's just kind of what I think of it as. And the vertex is on it, not in the center. Now, like I said, we know something about the measure of these inscribed angles. The measure of an inscribed angle is half of the measure of, we're going to call it the intercepted arc, or kind of the arc that it goes with. So let me show you on this one. Let's say it's the same arc I'm talking about, but they pull it all the way back. They take that vertex and they just stretch it here to the other side of the circle. Now it's an inscribed angle. It's half of the arc that it goes with. So that angle would be 20 if they stretch it all the way to the other side. That's really all that this first theorem is saying. So I don't know, let's just use this picture and let's throw some numbers at you. Let's say that, if you want to draw it, you can. So it's angle B is right here. Let's say that that's 21. You're either going to be dividing by 2 or multiplying by 2. If they give you the angle, you have to double it to say the measure of the arc, which is AC. So be careful there. And you don't need the picture, but I kind of like writing on it. Okay, same picture, this top here. Let's say they tell you AC, the arc is 70. You would need to divide that by 2 to get angle B there. Okay, so just know if you take the arc and you cut it in half, that's the inscribed angle. Okay, don't go the opposite way there, but that's what we're about to practice. So we got 3 examples. As you can tell, they can make the pictures a little bit wild with all the different diameters and radiuses and chords that they draw, but we're looking for inscribed angles. They could give me arcs, they could give me angles, they could ask me either one. First thing I'm going to do is just say, all right, the first thing I'm trying to find is the measure of angle ADB. So where is that? ADB. So I want to say this angle right here. Okay, that is an inscribed angle. The vertex is on the circle. It's formed by 2 chords. If you kind of extend the chords and then connect between them, that's just like what I do. See where they hit the circle, B and A. Connect between B and A. That's the arc that's associated with my inscribed angle. Okay, the angle is half of the arc. So we'll show you for visual sake. I just have to do 76 divided by 2. Sticky button there. And this guy would be 38. Okay, now they want to know what's the measure of arc DC. That's a minor arc, 2 letters. It's right here. Okay, I kind of look at like the endpoints, D and C. See how these 2 chords are forming that angle right there, 45? So like arc DC goes with this inscribed angle at B here, this 45. If they give you the inscribed angle, you double it to get the arc. All right, for example 2 then, so I only want to find one thing on this picture, and it's the measure of angle POQ. So find it first, POQ. I feel like I kind of like these because it's like a puzzle kind of. You just got to like piece everything together. Obviously, you have to use this 62 they give you. That's the only measure that I have, and it's the measure of an inscribed angle. So, all right, so I'm going to check out that angle here. Where it hits the circle is at P and Q. If I kind of connect between those, that's the intercepted arc that inscribed angle goes with. If I double 62, that tells me the arc that it goes with. So I know that arc is 124 degrees. Now check it out. That's the same arc that goes with this central angle. The angle I want to find, POQ, is a central angle. It's at the center. It's the same degrees as the arc. So that's got to be 124. These are fun. Everyone is different. All right, I'm going to leave you guys to this one, but I feel like I need to help you start. The first thing you want to find is A. So A is this arc right here. Okay, so look, ends at P and T. If you kind of like look at these chords here, see how this is the inscribed angle? That goes with A. So can you use that inscribed angle 60 to find how many degrees arc A is? Okay, fill it in. A is 120 degrees when you double that 60. So now to find angle B here, so bear with me, there's a lot of marks on the picture now, but here's B. That's my second part of this. I'm going to do this part for you. That's an inscribed angle. And if you kind of like look where it hits the circle, here at S and here at P, and you connect those, that's the intercepted arc. So it's 120 plus this 30. Yeah, that kind of covered it up there. But this whole arc is 150. I need to divide that by 2 to get the degrees for that intercepted or that inscribed angle. So 150 divided by 2, angle B would be 75. Okay, so it's just kind of a lot of like drawing all over it, dividing by 2, multiplying by 2. Takes practice, but we'll get there. We always do. On the back is the second theorem. So it's like the second part of this. It's kind of the same idea, multiplying by 2, dividing by 2, but the picture looks different. It's not an inscribed angle. So here's what the second theorem says. It says that the measure of an angle formed by a tangent line. So I'm going to draw this situation on my circle picture. We learned about tangent lines in lesson 3. Do your best. It doesn't have to be perfect, but like there's a tangent line. Remember, tangent lines like just graze the circle. They touch the circle at exactly 1 point. Maybe we'll call that BC. So that's my tangent line. We'll say like BC. Okay, so the measure of an angle formed by a tangent line and a chord. So what I'm going to do is I'm going to draw a chord on here. I'm going to call it AB. So the chord's going to be AB. So the measure of that angle formed by the tangent line and the chord, this is what they're talking about, that angle right there, like ABC. That angle, just kind of like how we saw on the front, that angle right there is half the measure of the intercepted arc here. And you're like, okay, well, what does that mean? The intercepted arc, let's use blue. It's the arc that's like kind of cut off by the chord. So like the chord hits the circle at A and B, between those guys, that's the intercepted arc here. So let's say they tell you that that arc is 100. That angle at B is half of that. So that angle down here would be 50 degrees. Okay, so it's same concept. You're going to be multiplying by 2, dividing by 2. Okay, maybe like, I don't know, draw a little note if you need to. Arc AB is the intercepted arc here. It's like kind of where the chord like cuts off the circle. That can be weird to see. All right, let's show you how to use this then. So 2 examples, then we're done. Example 1, here's that angle that they're talking about. It's an angle made between a tangent line and a chord. So you kind of look at where the chord hits the circle and look at it on the same side as X is, like over here on the right. This is the intercepted arc. If I can say how many degrees that is, I'm just going to divide it by 2 to get X. I obviously need to use this. 220 is like the other side of the circle. So I'm just going to do 360 minus 220, and that's going to give me my intercepted arcs degrees. So that's 140. If I divide that by 2, that's my angle. So that would be just 70. That's it. Arc divided by 2 is the angle on both sides. Angle times 2 is the arc. Again, same thing on both sides, just like different angle. These are fun. So a lot happened on this picture. This combines both theorems. So this is a good question. I'm going to do it with you. I only have one measure. So I obviously have to work around that and have to start by focusing there. And I notice, hey, that's an inscribed angle. The vertex is on the circle. It's made by 2 chords. I look where the chords hit the circle. If I connect between, I can double that inscribed angle, and I have the measure of that arc right there. So this arc is 108. All right, let's see how that's going to help me. Ooh, if you look at angle Z, you guys, angle Z is made by a tangent line and a chord. That's what this was. So if I look where the chord hits the circle, it's that same arc, 108. If I do 108 divided by 2, that's angle Z, so 54. Okay, so that's kind of nice. I do see a triangle in the middle. I don't know if you noticed this, but they marked it isosceles. So we'll redraw it here. Those 2 base angles should be the same. So I'm going to do 180 minus 54, split those degrees in half. Each side is 63 there, and that's actually what angle Y is. Like angle Y was one of those. So that's kind of nice. Lots of skills being used here. Okay, then the last one is I look at X. So X is this angle right here. It's made between a tangent line and a chord. If I look at where this chord hits the circle, this is my intercepted arc. So if I can find that, I'm just going to cut it in half. So check it out. This arc is 108. This arc is associated with this inscribed angle. I don't know how well you guys can see that, but if I extend Y, like the 2 pieces that make it, that arc goes with this. And this was 63 degrees, so if I just double that, that's 126. Okay, so I'm going to take my total 360, and I'm going to subtract off 126 and subtract off 108, like these 2 arcs. That's what's left over here, 126 degrees. And that's the intercepted arc for this angle X here. So if I divide that by 2, I can like jump down to the angle. So X would be 63. There's always a few ways to do this. Like, oh, maybe it'd have been way easier. Probably. And you're like, womp womp, sorry. These 3 angles make a line, which is 180. So you could have done 180 minus these 2. But it's good to practice with the arcs. All right, that's lesson 5. Practice it tomorrow. Like I said, I feel like this lesson's my favorite. You might disagree, but we'll find out as we practice.